Okay, so in the previous video, we were looking at two-way tables with two categorical variables. Now we're looking at two continuous variables. So this kind of follows on from the work we did on correlation last week, in that we're looking at relationships between variables. So let's do the usual and load in our data set. And we're going to be working with transactions. So just have a look what's in there. So again, like all these, they're just kind of little toy data sets. We have some purchase data. We have some demo on the customer. We have their satisfaction, whether they repeat purchase, gender, and income. For this exercise, we're just worried about purchase and income. So we want to know if the purchase amount is kind of related to people's income. And we want to do some graphs to look at this. Okay, so the first thing we do is we plot a scatter plot, and we're just going to use R has got a basic plot command. And what we're doing here, and we're going to come across this notation a lot when we move on to the rest of the course and regression. This just means we have purchase as the Y, and this little squiggle is just saying there's a relationship between Y and X. So Y squiggle X, this basically means we're going to plot this on the Y-axis, and we're going to plot this on the X-axis. That seems a bit counterintuitive that Y goes before X, but we will do more than this when we do models. The idea is you have your Y at your actual dependent variable at the left and your independent variable at the right. So as usual, we can plot the name of the plot, the labels, the X lab and the Y lab. We're going to make it a lovely chocolate color, and I'll explain what PCH does in a minute. So let's plot it. And we have a scatter plot, and there looks to be some relationship. Higher incomes tend to have higher purchase amounts. Okay, so let's just kind of go to, I've given you a little link here. Let's just go to that. Okay, so let's just, this is, I'd already had it up. Yeah, it's the same one. Okay, and what this does is PCH gives the symbol for the plot. So the two kind of things you want to understand is PCH is the symbol, and there's also CEX. PCH is the actual symbol. You can see here some example symbols. And CA, there's some other things here. You've got the color, the background, but CEX is the actual size of the symbol. So we can play around with this. So we had 16, which was a filled circle. Let's try 8, which is a star. And I also had a filled square, I think it was 15. So we're going to replace this, but this time we're doing exactly the same, but we're going to do PCH8. You see now we have a star. Now we're going to do PCH15. And with a square. Now let's just say CX1. This shouldn't change the actual graph. From that. So you see that's the same. That's the basic size. But say we want to make the squares twice as big, we can change that to CX2. We wouldn't really want to do that. That isn't a great graph, but there we go. Now let's plot the original graph again. And this is something I added. This isn't in the book, but just with this we'll do a lot of later in the course. But for the moment, just you don't have to understand it this time. What we're doing here is we're fitting a regression. The LM is how R fits a regression, and we have purchase in Y and income in X. And basically, it will fit a regression line. And remember, last time we drew AB line, and we drew an AB line across the bottom of the graph to give it a bottom. Okay, so this time we're just going to plot it with the regression line, which is going to be blue. And you can see that this is the line of best fit if we're doing a linear regression. Which you don't have to understand regression at the moment. You probably did it, obviously did it in business stats. But the idea would be that we're going to be doing more focus on regression as we get through the class. So we can see that there's this positive relationship. It's nowhere near a perfect positive relationship, but we can check the correlation. which is about just over 0.5. So kind of a moderate-ish, quite a reasonably large correlation between the income and purchase. And now again, I just want to build up your knowledge of ggplot. So here are some ggplot versions. So here we go, ggplot my data. The information we're going to use is on the X, we're going to have income. On the Y, we're going to have purchase. We're going to make it a lovely chocolate color again. We're actually going to draw this line. There's a ggplot function called gm smooth, and we're going to do method equals lm, which is linear regression. Then we're going to do the title and labels as usual. We're going to make it white background, and we're going to make the title in the middle. So let's just do a ggplot. There we go. And what's quite nice is it actually gives the error bars for the regression. So it gives a little confidence interval for the regression here, which is quite nice. And we actually, interestingly, ggplot has the same shape numbers as standard R plotting. You see it has the same numbers, but this time we use we actually use a shape command in geom_point. So let's just do geom_point. We're going to make it shape 15 and size 2. So it should look a little bit like the last one we did with squares and larger squares. And let's, rather than having a straight line, we can actually just do the basic geom smooth, which basically fits a regression that changes as it goes. This with span equals 0.5, we're just going to utilize, what that means is a span of 1, we utilize all the data when we're fitting it. The smaller the number, the more local the regression is. So here is span is 0.5, and you can see it's trying to fit a line based on the data. If we say set a span of 0.1, it would become much more sensitive to the data. You see that? It's jumping up and down. And a span of 0.8, it would become less sensitive to the data. There we go. So that is drawing a scatter plot to show the relationship between two variables. Again, first we used the standard plot, and then I added some variance with ggplot.